Okay, this video covers section 2, part A of practice exam 2. And so on this one you do get to use your calculator, so that's going to be really helpful. You have 30 minutes, so you think of it as about 15 minutes per problem. Although probably number 1, which is all I'm going to cover in this video, you could probably do in maybe less than 15 minutes. Okay, so number 1 says let R be the region in the first quadrant enclosed by the graph of y equals 2 cosine x, the x-axis and the y-axis. So you can graph this on your calculator if you need to, and I'm going to graph it over here. Y equals 2 cosine x. Cosine starts up on the y-axis. Since it's 2 cosine x, it'll start there. So we're talking about this area right here. And if you want to know where it crosses the x-axis, because we're going to need to know that, it's where does 2 cosine x equal to 0. So that'd be cosine x equals 0, and you know that cosine x is equal to 0 at pi over 2. Okay, you could do that on your calculator, but it's a lot faster to remember from the unit circle that cosine is 0 at pi over 2. So part A says find the area of that region. Okay, and they named that, let's try green. Region R. Okay, so part A, area is just going to be top minus bottom. Okay, and so we're integrating from 0 to pi over 2 of 2 cosine x dx. Okay, and just put that in your calculator. All right, and when you do, you'll get an answer of 2. Okay, so you want to write out the integral just like this. Make sure you don't forget the dx, and then just circle your answer, and you're good to go on that. Okay, part B says if the line x equals a divides the region into 2 regions of equal area, find A. Okay, so I'm going to go back to this. And we've got that area there. And we have a line here that divides it into regions of 2 equal areas. So at point A. Well, if the area of the whole thing is 2, then the area of half of that, 2 equal areas, is just going to be 1. So we could set this up as 0 to A of 2 cosine x dx. That's the area from 0 to A is equal to 1, since it's half of it. All right, integrating 2 cosine x, that's going to be 2 sine x. Evaluating that from 0 to A equals 1. So that's 2 sine A minus 2 sine of 0 is equal to 1. Sine of 0 is 0. So we'd have 2 sine A is equal to 1. So sine A is equal to 1/2. Well, what angle has a sine of 1/2? Well, you've got to remember the old unit circle, but the angle that has a sine of 1/2 is pi over 6. Right, so that is your answer to part B. So hopefully you're starting to get a little more comfortable with solving for something you know the final answer, but we're solving for one of the limits of integration. We did one of those with K in yesterday's video. Alright, so I'll give you a second to write that down. Okay. So boom, parts A and B are done. Let's try part C. So it says find the volume of the solid obtained by revolving region R about the x-axis. Okay, so let's get all this stuff out of the way. And I'll just draw the whole thing again. Alright, there's our region R. We're revolving it around the x-axis. So I'm going to go ahead and draw that symmetrical side. And there's no hole in this, so this is a good old disc. Poker chip. Alright, we know we are at pi over 2 here. So we're going to sum up all those discs from left to right, from 0 to pi over 2. So volume is going to be pi. We're going from 0 to pi over 2. And then the radius is just the height. It's just 2 cosine x. So 2 cosine x dx. But we have to remember, to square the radius. So again, pi r squared. But your calculator does all the work for you. All right, so looking at the answer that you'll get, if you put all that into your calculator, it should be pi squared. If you do it in decimal, of course, it would be 3.1415, all that squared. Okay, so if you do it in decimal format, just make sure you carry it out at least 3 decimal places. And don't forget to square it like I almost did. Okay, so let's see if we can fit part D on here. Alright, part D says if R is the base of a solid whose cross sections are perpendicular to the x-axis are semicircles, find the volume of the solid. Alright, so I'm going to draw the thing again. I'll probably regret not erasing. So what it's saying is that perpendicular to the x-axis, we've got semicircles. Okay. So if I were to chop all of this area from 0 to pi over 2 into semicircles, then what kind of total volume would I have? Okay, the area of a semicircle is just half of the area of a circle. The area of a circle is pi r squared, so it's going to be pi r squared over 2. So what is r? What is the radius? Well, the radius is just going to be the height, which is 2 cosine x, right? So radius is 2 cosine x. So to get the volume, we just want to sum up all the areas of these semicircles from 0 to 2 pi. Now, I'm going to have, so that's going to be 0 to pi over 2, not 2 pi, sorry. Pi over 2 of pi times the radius squared, 2 cosine x, all squared, over 2 dx. Now you can bring that pi over 2 out front. That might be easier when sticking it into your calculator. Alright, but let the calculator do all the work. And what you'll get, go ahead and give it a try, is pi squared over 8. Again, if you do this in decimal, then make sure to carry it out three places. Okay, so we've gotten a couple of problems in the last couple days on this practice test where we're having to do semicircles. So that could happen to you. You're usually just looking at semicircles, squares, and rectangles in terms of having to chop up volume into a specific shape. All right, and that is not something that we looked at in our textbook. So anyway, that is number 1, and it took less than 10 minutes, and that was with me explaining it to you. All right, so you could knock this one out pretty quick, I think. So that ends the video. Practice test 2, section 2, part A, number 1.